Welcome to the presentation on lung volumes, and what I want to do in this particular video is I want to simplify this idea of lung volumes. I do have the impression it's one of the simplest concepts in sport and PE, one that we either teach badly or learn badly or some combination of both, and for some reason people get confused about it, and I want to kind of simplify it really. I'm going to use the idea of spirometry, okay, immediately complicating the actual subject. Spirometry. Spirometry is actually a measuring technique. We use a spirometer to measure the volumes the quantities of air that are going into and out of lungs. And you've got the setup here. You can see that this chap, or this illustration of this chap here, he's breathing into a tube, and that tube is taking this air into this sort of bell jar here. And as he breathes in, this little object here rises. So this object here rises, okay, as he breathes in, and that means that this little pencil moves upwards. And as he breathes out, it moves downwards. So this thing then moves downwards. And as this paper rotates around, you get this kind of spirometer trace on here. And I've got an illustration of that, or the example of what might be a spirometer trace over here. So let's imagine, first of all, that we are breathing at resting conditions. So I'll give you a loud version of my breathing. It might be something like this. Okay, so that's a loud version of me. So sorry if that seems weird somehow. But as I breathe in, okay, so as I breathe in, the trace goes up. And as I start to breathe out, the trace goes down. It goes up and it goes down. Now you can see first of all that the difference between in and out is 500 milliliters. Okay, so the normal in breath and the normal out, the standard in breath and the standard out breath at rest is about 500 milliliters, and we have a name for this. It's called your tidal, just write that in, volume. So the tidal volume at rest for the average person is 500 milliliters. And you can see that here, right? 500 milliliters tidal volume. So just to remind you, it's the quantity of air breathed in and out during a single resting breath. Now, the thing to say about tidal volume is it can get bigger, and it can, when we breathe in, and it can get bigger when we breathe out. So in other words, we have a reserve on our inspiration, our breathing in, and we have a reserve on our expiration. So if I take a maximal in breath, so that's going to be from here, I'm going to sort of make that funny sound now and do a maximum breath in. 3, 2, 1. Okay, in that breath, I've got a lot of breath, don't need to breathe for a little while now. In that breath now, we see the curve shoots up to a much higher quantity, and that makes sense, right? Rather than me just breathing in, I'm now breathing in. A big breath, and I use up my inspiratory reserve volume, my IRV. I have an extra reserve, and it's about 3 litres worth, or 3,000 milliliters. I've got a reserve of more air that I can breathe in. In other words, I've got an additional capacity in my lungs for me to take a deeper breath. Now, I want to stress here that we are using up the inspiratory reserve volume, and by that, we are actually increasing tidal volume. So by using up inspiratory reserve volume, our tidal volume gets bigger. And in this case, it goes up to about 3.5 litres. So that big in-breath is around about 3.5 litres. Equally, if I do a forced out breath from here, just change colour, okay, if I go and breathe out as much air as I possibly can, okay, we've got, it would actually, we just do a normal breath there. Okay, it comes down here. We use up our expiratory reserve volume. So we use up that additional space to get rid of more air, the expiratory reserve volume. Okay, so that's the maximum amount of air that we can breathe out. And you can see here it's slightly smaller. It's around about an additional 1 litre, just over 1 litre, which means our expiration is around about 1.5 litres. So we can breathe in around about 3.5, and we can force out around about 1.5 additional amount. Okay, so in total, we end up what we call our vital capacity is around about 4.6 litres. Okay, so 4.6 litres. But we do have a volume of air, it's down here, look, which we cannot breathe out. So you notice that this doesn't come all the way down here. We cannot breathe out this sort of 1.2 litres at the end. It stays in our lung all the time because it prevents any kind of collapsing or folding down of the alveoli, and we call this the residual volume. The residual volume, and you'll see there that it's around about 1.2 litres, and that stays in the lung all the time, prevent the sort of folding down and damage to the actual lung tissue itself. So a couple of things I want to say is that tidal volume plus inspiratory reserve volume plus expiratory reserve volume equals what we call our utilizable capacity. And we have a name for this. It's called your vital capacity. This is the amount of usable space in the lung. And you see it here. We have this vital capacity down here, which is our tidal volume plus our inspiratory reserve plus our expiratory reserve. It's our vital capacity. It's the utilizable space within the lung. And you can see here that it's around about 4.6 litres. So it's around about 4.6 litres of air that we can get in and out of our system when we're exercising at maximal forced breathing. Okay. Now then, other lung volumes I want you to be aware of. You can see that total lung volume is 4.6 plus the 1.2 of the residual volume we can't move out. So almost 6 litres of air can be in the lung, or we can get into the lung, but we can only get 4.6 of it out. Now then, other things I want you to be aware of is this vital capacity. Okay, this is how much we're capable of breathing within one single in and out breath. But what if we were sort of calculating by the minute? Okay, so we've got an equation for that. The amount of air we breathe in and out during a minute is what we call our minute ventilation. Our minute ventilation, okay? And minute ventilation equals our amount that we're breathing in and out per breath. So of course this is our tidal volume multiplied by, well, what would that have to be to get the amount of air per minute? Well, of course it would have to be breathing frequency, and we sometimes call this pulmonary frequency. Breathing frequency, so how many times we actually breathe per minute, and we can therefore calculate our minute ventilation. So it's our tidal volume multiplied by our breathing frequency. Okay, our breathing frequency. So we can calculate this concept of minute ventilation. Okay, that's all from me right now on lung volumes. Hope that's been useful for you, and do tune in for future videos. Thanks very much.